DevOps and CI-CD Part 13. This episode has 4 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain namespaces in Linux. Here's a strong way to approach it. What are Linux namespaces? Linux namespaces are a kernel feature that provides isolation of system resources for processes. They are one of the core technologies behind containers such as Docker and Kubernetes. A namespace makes a process believe it has its own dedicated view of a resource, even though the underlying system resources are shared. Why namespaces? Without namespaces, host process A, process B, process C, all processes can see the same process IDs, network interfaces, mount points, host name with namespaces. Container A, container B, process 1, process 1, process 2, process 2, process 3. Each container sees its own isolated environment. Types of Linux namespaces. 1. PID namespace isolates process IDs. Inside a container, PSF you may see PID command 1 ginks 2 worker. The container cannot see host processes. 2. Network namespace, NET, provides isolated IP addresses, routing tables, network interfaces, firewall rules. Example. Container A 172.170. 2. Container B 172.170. 3. Each container has its own network stack. 3. Mount namespace, MNT isolates file system mount points. Example. Container A or app, container B or app both may have different contents despite the same path. 4. UTS namespace isolates host name, domain name. Example. Host name container A, web01 container B, DB015. IPC namespace isolates interprocess communication resources. Shared memory message queues, semaphores. Processes in one container cannot access IPC resources of another container. 6. User namespace isolates user IDs, UID, group IDs. Git example. Container root, UID 0. Mapped to host UID 100,000. A process may appear as root inside the container but not have root privileges on the host. 7. C group namespace isolates visibility of control groups. Containers see only their own resource limits. How Docker uses namespaces. When you run Docker run ginks, Docker creates namespaces for PID, NET, MNT, UTS, IPC user. Optional. C group result. Container own processes, own network, own file system, own host name. View namespaces on Linux. LSNS shows all namespaces on the system. Example. IPNetNS list shows network namespaces. Namespaces versus groups feature namespaces. Groups purpose isolation, resource limiting. Example. Separate process table limit CPU or memory. Container visibility restricted controlled function. What can I see? How much can I use? Interview answer. 7+ years experience. Linux namespaces are a kernel feature that provides isolation of system resources for processes. They form the foundation of container technologies such as Docker and Kubernetes. Different namespace types isolate processes. PID, networking, NET, file systems, MNT, host names, UTS, IPC resources, users, user, and C group visibility. By creating separate namespaces, containers obtain their own isolated view of the system while still sharing the host kernel. Namespaces work together with groups, which enforce resource limits, to provide secure and efficient container isolation. Nice. Let's continue. Question 2. What are groups? Here's a strong way to approach it. What are groups? Groups, control groups, are a Linux kernel feature used to limit, prioritize, monitor, and isolate resource usage of processes. While namespaces provide isolation, groups control how much CPU, memory, disk I/O, and network resources a process or container can consume. Why do we need groups? Without groups, container A uses 90% CPU, container B starved of resources. One application can consume all system resources. With groups, container A CPU, 2 cores memory, 2 GB, container B CPU, 1 core memory, 1 GB. Each container gets controlled resource allocation. Resources managed by groups. Resource example. CPU limit CPU cores or usage, memory limit RAM usage, disk I/O control, read or write rates, network prioritize, network traffic processes limit number of processes, PIDs. Docker example. Limit memory, Docker run D, memory equals 512 M ginks, limit CPU, Docker run D, pus equals 1 ginks, limit both, Docker run D, Memory equals 1G. Pus equals 2 ginks how grups work host OS grups container a container B the kernel enforces resource limits for each group of processes common C group controller CPU shares CPU quota CPU affinity example Docker run Pus equals 2 ginks memory controller memory limits OOM handling swap limits example Docker run memory equals 1 gene ginks PID controller limits the number of processes Docker run PIDs limit equals 100 ginks prevents fork bombs and runaway processes block I or O controller controls disk throughput. Read rate write rate IO priority Kubernetes and grups pod resource requests and limits are enforced through grups. Example, resources, requests. The exact commands and code are in the written question bank. Great, moving on. Question 3. Explain container security. Here's a strong way to approach it. What is container security? Container security is the practice of protecting containerized applications, container images, runtimes, registries, hosts, and orchestration platforms throughout the application lifecycle. The goal is to ensure confidentiality, integrity, availability, compliance of containerized workloads, container security layers plus, application security plus, container image plus, container runtime plus, container host plus, registry security plus, Kubernetes security plus, infrastructure plus, +1, secure container images use trusted base images good, from Ubuntu, 24.04 better, from Alpine, 3.22 use official and verified images from trusted registries, scan images for vulnerabilities tools, Trivi gripe Claire example, Trivi image myapp, v12. Run containers as non-root avoid, user root use, run aduser abuser this reduces privilege escalation risks 3, minimize image size use, Alpine images Distroless images smaller images, reduce attack surface improve startup times 4, protect secrets never store secrets inside images, bad, NVDB password equals password 123 use, Kubernetes secrets external secret managers examples. HashiCorp Vault Amazon Web Services Secrets Manager Microsoft Key Vault 5 Runtime Security Limit Container Privileges Docker Run Read-only Cap Drop All MyApp Use Read-only File System Drop Unnecessary Linux Capabilities Restrict Privileged Containers Avoid Docker Run Privileged unless absolutely necessary 6 Kernel Security Features Secomp restricts Linux system calls Container The exact commands and code are in the written question bank. Alright, next question. Question 4. What is rootless Docker? Here's a strong way to approach it. What is rootless Docker? Rootless Docker is a mode in which the Docker daemon and containers run without root privileges on the host system. In traditional Docker, the Docker daemon, Dockered, runs as root, which means a compromise of Docker could potentially lead to full host access. Rootless Docker reduces this risk by running Docker entirely as an unprivileged user. Traditional Docker versus rootless Docker. Traditional Docker user Docker CLI Dockered, root. Containers rootless Docker user Docker CLI Dockered, non-root. Containers how it works rootless Docker relies on user namespaces rootless Kitslurp for nets, networking fuse overlay storage. A container may appear to run as root inside the container, but it is mapped to an unprivileged user on the host. Container UID 0, root host UID 1000 non-root. User benefits. 1. Improved security even if a container is compromised. Container escape non-root user the attacker does not automatically gain root access on the host. 2. Reduced attack surface no root owned Docker daemon is exposed. 3. Better multi-user environments useful on shared servers development workstations CI/CD runners installation on modern Linux distributions. Dockered rootless setup tool sh install start service system tool user start Docker check Docker info output includes rootless true limitations rootless Docker has some restrictions feature rootless support privileged containers cross-mark host network mode cross-mark some low-level kernel features cross-mark standard containers checkmark volumes checkmark build images checkmark when to use rootless Docker checkmark developer laptops checkmark shared Linux servers checkmark CI/CD environments checkmark security conscious deployments less suitable when workloads require Privileged containers, direct host networking, certain kernel-level operations, rootless Docker versus running a container as non-root. These are different concepts. Feature: rootless Docker, non-root container, Docker daemon, non-root root container, process, non-root mapping, non-root user inside container, security scope, entire Docker stack, application only for maximum security. Use both. Rootless Docker, non-root application users inside containers. Interview answer: 7+ years experience. Rootless Docker is a deployment mode where both the Docker daemon and containers run without root privileges on the host. It leverages Linux user namespaces to map container root users to unprivileged host users, significantly reducing the impact of container escapes and daemon compromises. Rootless Docker improves security and is particularly useful in multi-tenant environments, developer workstations, and CI/CD systems. While it supports most standard container workloads, it has limitations around privileged containers, host networking, and certain kernel-level operations. For defense in depth, rootless Docker is typically combined with non-root container users and least privilege security practices. Let's keep going. That wraps up this episode. Nice work practicing, and see you in the next one.